Hi, I'm Dylan Taylor, Chairman and CEO of Voyager Space Holdings.
I'm Ken Eppins, founder and CEO of Orbit Guardians.
Hi, I'm Raphael Rodkin, founder of E2MC Space Ventures.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
This show is for entertainment purposes only and is not what is termed professional advice. The Cold Star Project is proudly presented by the Operational Excellence Society. Cold Star Tech is a supporter of the OPEX Society, and Jason Kanigan is a member of its board of advisors. Talk with us at Cold Star Tech to find out what we can achieve together with your Lean Six Sigma or Operational Excellence programs. And check out opexsociety.org to learn more.
I'd also like to remind you to check out the America's Future series, the non-political speaker series on U.S. national security and space and defense. Great discussions. Cold Star Tech is a promotional partner of the America's Future series and vice versa. You can check out their website at americas-fs.org. Today's guest continues the conversation about developing technologies for space and defense. It is not that easy, especially when you're trying to commercialize them. Just because you can create a result, just because you can create a reaction, does that mean that you should go and try and create a saleable product with this? So my guest today is Dr. David Driscoll. Dr. Driscoll is first a graduate of Montana State University. So David finished his engineering doctorate and is now a faculty member at MSU as a senior research scientist. He's been the president of Glacigen Materials, which is the company that we're going to talk about today. And he's currently the president at Storm Castle Technical Products. So this is a very interesting discussion on the difficulties of commercializing something that you've developed. Even though the result works, the functionality of the product works, turning it into something saleable, there's more to it than that. So David, welcome.
Okay, I guess let's talk about your background initially then. Where are you coming at these challenges from that we're going to discuss?
Yeah, so by way of education, I have a bachelor's degree in mechanical engineering. I went straight on to a PhD that's also tagged mechanical engineering, functionally material science, though. My thesis work focused on increasing the lifetime of solid oxide fuel cell anodes. And so truly a mixed bag that meshes in a way that's sometimes pretty advantageous.
Awesome. Okay. And you've held some great professional roles. Let's talk a little bit about that, Montana State University in particular.
Yeah, so at present, I'm a senior research scientist at Montana State University. We are conducting primarily solid state battery research funded by the Army Research Lab. In addition to that, I actually came to Montana State out of having co-founded Glacigen Materials, which was a startup that we'll get to talk about in some detail today, but really found its pathway in advanced manufacturing processes aimed at solid state batteries. And so it was a very natural segue into the work at Montana State.
Excellent. Okay. So yeah, let's talk about Glacigen. What's it all about?
Yeah, Glacigen was really founded around a technology, specifically freeze tape casting. Freeze tape casting is a hybridization of one very well known technology, that is tape casting, and it's a ceramic production technique that's been used in industry for a very long time. It makes large area thin sheets of material at very high rate. But that known technique was hybridized with something called freeze casting or ice templating, depending on who you ask. And the idea is that, when we process ceramic materials, almost always you have them in a powdered form suspended in something that might be similar to latex house paint called a slurry. And you can form those in any number of ways. You can cast them, you can extrude them, you can spray them. But we in almost any case deposit this slurry and then evaporate the solvent out so that we're left behind with a dense material. In the case of freeze casting or ice templating, instead of evaporating the solvent, you freeze it. And you do that in a way that's directional and a way that's controlled. And if you do it correctly, you can use the growing ice to actually template microstructures. And so we're talking about features in the material that are something less than 100 microns in terms of size scale. You pull that solvent out, and suddenly you can take materials that were relatively benign, and you may have imparted functional properties by the way you've physically arranged that microstructure.
Okay. Tell us a bit more about that. Some examples, maybe.
Yeah, so we've looked, as you might imagine, at all sorts of applications for the FTC process, ranging from catalyst beds to solid oxide fuel cell electrodes, which is where this has all started. Things like nonlinear springs and actuators, filters, and then most recently battery electrodes, where one of the unique features of a freeze cast microstructure is that you can generate this anisotropy, so properties that vary depending on the direction in which you look at them. One of the things that we can do is create pores or open channels that extend continuously in a straight line from the bottom of a sheet of material that we've produced through to the top, like a bunch of many millions of straws arranged vertically. And so when you have something like a battery electrode that really functionally is predicated on being able to move mass through the thickness of that sheet of material, these structures can be really advantageous.
Okay. Very, very interesting. So was this developed as a SBIR or an STTR or something else?
Yeah, so this was really pioneered originally as technology in-house by the guy I studied for my PhD, Stephen Sovey at the NASA Glenn Research Center. NASA at that time was heavily focused on advancing solid oxide fuel cell technology. This is one of the things they were looking at doing. So he brought that with him to Montana State, where I was exposed to it during my graduate studies. And really what caught me is, like so many advanced techniques, it was really neat with a lot of potential that wasn't being realized. And what would happen is that whether in publication or at conferences, folks would see these microstructures, get excited about it, say, I want to try that. And they would fail miserably, despite being smart people putting their best efforts together. So often the science blurs the line with art, right? And it can be very easy to end up with techniques developed in the laboratory that feel very much like, yeah, it works, but you stand on your right foot while you're rubbing your tummy and patting your head in order to make it work. And I guess the opportunity that I saw and another view on the launch of Glacigen was kind of accepting the intrinsic value of being able to provide microstructural order in all sorts of materials, but in codifying and then not doing very fundamental research, but now the engineering on the manufacturing process so that it becomes repeatable. Okay, right. As you pointed out in our notes, as with many things developed this way, it was kind of a solution looking for a problem, right? Who is the customer here? What's their pain point? Yeah, that's absolutely true. So we launched Glacigen with 3 simultaneous phase 1 SBIRs, ranging from SOFCs for the Department of Energy to advanced composite materials for NASA, where we were using this process to create a microporous ceramic that could be backfilled with a metal, which had its own unique mechanical properties, to a Navy project looking at applying it to thermal interface materials. And in essence, indeed, a solution looking for a problem. And so we started investigating any number of application areas where we felt there was a good technical fit and a capacity to impart real benefit. And that, that wandered around for some time. We spent probably fully 18 months feeling very application agnostic. And in fact, that led toward kind of a view of the business model that was really expertise in a manufacturing process, maybe ultimately transitioning towards an equipment manufacturer that would support any number of applications. It was a little bit down the road for the company that we found that focus with respect to batteries.
Okay. Right. Because, yeah, you have this methodology and this idea, and then it's like, okay, where do we use it? But then also, I think you have a problem in terms of scale in manufacturing as well, right? How do you make a lot of this stuff at an affordable rate, right? Where there's an ROI. Was there a challenge in that area?
Yeah. Oh my goodness. Enormous. One of the things that was an embarrassment on day one, which we recognized and said we're going to solve this, and I think we actually did pretty well, is that these things are often quantified in terms of machine rate. So you're extruding this thin film, and you can make the caster however wide you want within reason. You might have a film that's 4 inches wide, it might be 24 inches wide. But then how quickly does that film extrude outwards, right? And the highest rate lithium ion manufacturing, which typically is closely related slot die coating, not tape casting, you're talking many tens of feet per minute. Freeze tape casting, when controlled properly, came out of the university measured in microns to millimeters per minute. And that hurts. And we said, we know there's a way to really not incrementally improve, but shift the paradigm and how we think about the process and move it to a rate that's much faster. So the final laboratory scale machine that we produced had a maximum production rate of about 5 feet per minute. And so we crossed several orders of magnitude in a few years. But you're absolutely right in that focusing on the nitty gritty of some aspect of technical merit while not acknowledging what are real game show stoppers, right? Game stopping limitations. That's a serious problem.
Was there ever a point at which you were like, I think I kind of want to give up on this and move on to some other idea?
Yeah. That and that remains the constant challenge, right? Where I feel strongly that as entrepreneurs, we need to be honest with ourselves. And when we recognize something that's truly going to impede us getting to where we want to go, especially as technologists who have a capacity to do a technical analysis that others may not, well, I do think we need to be honest enough to pull the plug when the game should stop. But at the same time, you run the risk, of course, of doing that prematurely and maybe not making progress where a lot of opportunity exists. And so I certainly felt that in the first years of Glacigen, where we look forward and see a big gap between where we're at and where we need to be. And I'll state that when we crossed several orders of magnitude in terms of production speed, that was as close to a light switch moment as it gets, where we had been trying to work within what I'll describe as a paradigm for the processing conditions and advancing it. But you can't make 20% improvements on something that's 10 to 100 times too slow. And we had a number of brainstorming sessions where we say we're going to start with a clean sheet of paper and we're going to go at this. And it was the third or fourth of those that the brainstorming session got it right, and we did that.
Okay, so be prepared. See, the reason I want folks like you on is to share these stories about, look, it's great maybe that you applied for and you want a SBIR, but now what, right? And there are a lot of challenges that are going to come up during the investigatory process and then after. And, I think the takeaway here is you should always be thinking about commercialization. How many years have you been working on this particular project?
Yeah, so this is something like 7 or 8 years of active work for me at this point. And after that length of time, you'll note that at present, we've got it back in the university, which relative to its TRL, I think is really the right place for it to be a bit longer.
Okay. And you've started up your own company as well in between. Tell us a little bit about that.
Yeah, so I am scaling back my time at the university. As some of us are wired that way, I tell people that a regular paycheck and 9 to 5 hours made me itchy after a while. And so I've launched Storm Castle Technical Products. We were just last week given our first phase 1 SBIR. And that's also a ceramics processing company, but a very different flavor than what Glacigen was. I'm working on inflation systems for atmospheric reentry devices.
Okay.
The high level there is that, of course, there is a solution space for vehicle size and vehicle mass that can be brought back down out of orbit depending on the atmosphere you're reentering into. And as part of essentially expanding that design envelope, HIAD has come forth. HIAD, H-I-A-D, stands for Hypersonic Inflatable Aerodynamic Decelerator. And the concept is essentially that you put a great big balloon in front of the spaceship, you put a heat shield over that, and you expand it much like a backwards umbrella. And in doing that, you've now decoupled the frontal area of your reentry system, which is creating drag, from the diameter of your vehicle, which is something that's not done otherwise. And as part of that, there is a need for advanced systems to provide the gas to actually inflate the HIAD. And it's a more challenging problem than some people might anticipate at first glance. We've identified the technology for doing that. I'm not the origin of that technology. My role in this actually is that this is done with a solid state chemical reaction. And building the cores of these generators requires some real tricks in ceramics processing. And so my role here is in thinking about how we take that from the lab bench to something that can be manufactured at a useful scale.
Which, as we have seen, can be quite a challenge. All right. I'm always on the case of university students to start networking now. For example, right? Don't wait until the end of your 4th year, your final year, or whatever, and then suddenly realize, oh, geez, I got to get a job. Start it in year 1, year 2, right? Thinking along those lines, what advice would you have to people, principal investigators, that getting SBIRs and STTRs and awards now and working on projects regarding commercialization?
Yeah, talk to everybody and do it frequently, and most assuredly, don't think that at any point it's too early to start talking. Now, in those earliest stages, when the technology is a baby, don't overrepresent what you have, right? Don't set up false expectations, but do know where you're at and present yourself appropriately from that platform and have a vision of where you're going and check that with people. There are I honestly can probably think of half a dozen crossroads for Glacigen, where if we had done that effectively, and by the way, I'm saying this from a place of experience, because in the early days of Glacigen, I thought we were talking to people, but we weren't necessarily talking to the right people, and we weren't doing it as often as I think we could have. And based on the lessons having come out of that, I really think that if I were to not have the technical knowledge that was developed, but the business experience and go back to the beginning of Glacigen's path, I probably could have come to the same conclusions that we ultimately arrived at in quite literally a third of the time that it took. And the sole difference would have been talking to the folks who would really be the customers for this technology in an informed way.
Rather than just staying in an ivory tower and figuring, technically we'll figure it all out, but
yeah, that's right. And I remember pretty vividly people giving me that advice, and I don't know what to say, except that an engineer can maybe talk about the statics and dynamics of riding a bicycle and put together 5 or 10 pages of math on it, but you just don't understand riding a bicycle maybe until you've done it. And so I would say that when folks say network and do it seriously, from a more informed vantage point, I can say that's really, really true. And make sure that when you think you're doing it, you're actually doing it. And maybe one of the tests for that is that if you aren't feeling truly challenged and you're not feeling that you're having holes poked in your plan, you're probably not talking to the right people.
Okay. Yes, because that's some good advice there. Who are the end users? You want to get into contact with them and find out how they're going to use it and how even they're going to receive it. But also, I'm thinking like, does it come on a truck in a tank? What, how much volume does this need to show up in? How's it going to be put into their product, right? And added in, and that's going to teach you how to organize things up the supply chain for yourself, right? But also not just finding other technical people to talk about how cool it is and maybe impress them, but also maybe people to tell you, yeah, this might not work, or this might be wrong, or here's a place you're going to fall down.
No, absolutely right. And, as you allude to, there's lots of folks to be speaking to outside of customers, right? The challenge of launching a new firm around an SBIR, STTR award is that they're very limited in scope, right? Both in terms of funding and duration. And boy, you're just not going to know everything on your own. There's no way. And if you're truly the smallest of firms that are represented by SBIR, which, by the way, I support, and I think it's in the spirit of these awards that are supposed to spur innovation. We acknowledge that and say that's good. But say we live in a big, complex world where a lot of problems have already been solved, and seeking out the folks who have those solutions is just part of being effective.
Okay. David, can you give us a snippet of what to do when you want to approach a university to potentially partner with you? How do you at least open that conversation? Is it a program head you go to, or who do you approach, and what are the first kind of opening lines that you might want to start with?
Yeah, that's a really good question, and I would say there's two pathways which frankly could be pursued in parallel. But one is to go to the business folks, and the university will have the technology transfer office, or something that's called something very close to a technology transfer office. And universities love to see their technologies licensed, right? And so there's a team of administrative and typically very savvy folks who are interested in making that happen. So if you approach them, they're going to approach that conversation with open arms and say, let me search out and see who we can connect you with. Okay. That'll be a very mission-focused discussion, right? Here's my technology area. Here's what I'm trying to do. Do you have somebody who can help me? What I think is going to be much more effective, though, and what those folks in technology transfer are ultimately going to do, is search out the faculty with the right technical expertise and try to get that person interested. And what you really need to be doing if you're interested is be reviewing the literature, be reviewing the conferences, and have a really good handle on who's doing the work that's relevant to the need that you have. And what I would find in almost every case, at the university, we see quite a few of these messages come across our desk with all sorts of flavors of requests for collaboration, et cetera. And a lot of them feel like spam, and there's simply not time to respond. What becomes very different is, hey, Dr. So-and-so, I was reviewing your paper on this. It's related to work I'm trying to do in this way. I thought this and this was pretty insightful. And it seems like even though it wasn't the focus of your paper, your laboratories might have capabilities of doing this. Can we have a conversation to gauge your level of interest? And boy, everybody will bite on that. Nobody will tell you no. And so you have that initial conversation. And if you can build, you've got to realize that, especially if you're doing this in the sense of an SBIR or an STTR, and we need to separate those at this point. An SBIR contract is really a pain for a university faculty member. It's not enough money to be significant. And the timescales are so short. You get your students spooled up, you get the contract in place, it's half over. The student starts taking classes for the semester, and it's really hard to get much done. STTRs, by nature, of course, are intended to have a technology coming from the university, ultimately to be licensed by the company as the ideal model. And faculty obviously are going to be excited if there's a company who wants to use the thing that they're going to be doing. But the point of recognizing that whether it's an SBIR or STTR, which can be more functionally interesting just because more cash is available to the university, it's not the award, and certainly not the time scale that's going to get anybody there interested. It's seeing the potential of a commercial pathway for a technology that was developed in a university lab. And so that vision has got to be clear, and you've got to be able to communicate that.
Okay, well, thank you for a very valuable response. That was a kind of an off-the-cuff question. It wasn't on our sheet, but you had a great answer there. All right, David. So who do you want to be connecting with? Who would you like reaching out to you, and how would you like them to do it?
Yeah, that's a great question. Let me say in a general sense, Storm Castle Technical Products intends to grow in a way that really leverages identifying promising technologies that low to maybe mid TRL level, that has specific material processing challenges that are a technical barrier to advancing to the next level. And for folks that find themselves in that position, I'm excited to work with you and would like to do that. And frankly, I think my email address is the way to go. So it's David, D-A-V-I-D, at stormcastletechnicalproducts.com. All one long string, products is plural. And if you have something that you feel really has potential, but we try to go from very small batches on the benchtop to anything larger and have 15 different problems. Those are the things that Storm Castle is well equipped to think about, and I'd be happy to do that.
All right, fantastic. Thanks for doing this.
Glad to do it, Jason. I appreciate the invitation.
So some valuable feedback from David there on the challenges in developing a scalable production business when you've got a material science product that you could create. The question is, can it be turned into something commercial and actually make you money and do a service for a customer, right? So David has that experience. He knows what it's like, and I think you'd be well advised to go speak to him if you're in that low TRL scale and want to learn and not get punched in the nose so hard when it comes time to scale. On the commercial side also, I'm thinking more on the marketing side, positioning side. You could come to talk to us at Cold Star Tech and we could help you with that. Thanks for tuning in, and we'll see you next time.